Hello, I am Kiran Kumar from Nature of Physics. One question I will read. A particle executing SHM on a straight line at two positions, its velocities are u and v, while accelerations are alpha and beta respectively. Beta greater than to alpha greater than to 0. The distance between these two positions is asking in the question. Wait a second. According to the question, displacement is x1, velocity is u, and acceleration is alpha given. Okay, and next, displacement is x2, velocity is v, and corresponding acceleration is beta given. The condition according to the question, beta greater than to the alpha greater than to the 0 given. So that I am going to find here first relation from the simple harmonic motion. So from the simple harmonic motion SHM, so that acceleration alpha is equal to minus omega square into x1, and second equation beta which is equal to minus omega square into x2. Using the both equations, so that equation 1 plus equation 2, so that alpha plus beta which is equal to minus omega square x1 plus x2, okay, and alpha plus beta divided by minus omega square which is equal to x1 plus x2. This I am writing as equation number 1. Okay, and then continuation, next step is velocity relation, student. So for velocity relation, velocity v is equal to omega root over a square minus y square, but here we are considering x, so that I am writing x. Okay student, so first one basic equation I gave you. After that I will write the according to the given values from the question. See there, so first one is there initial velocity u given, so that initial velocity u which is equal to omega into root over a square minus x1 square, and final velocity which is equal to omega root over a square minus x2 square. Both equations are there, and here also using both equations and finding the relation like this. So first equation square minus second equation square. So first equation is u square minus v square, LHS side completed, and RHS side is omega square of a square minus x1 square root of get cancel minus omega square a square minus x1 square root of get cancel, so that u square minus v square which is equal to omega square is common, a square minus x1 square minus a square plus this is x2 student, okay, plus x2 square, minus of minus plus. So a1 square, sorry, a square get cancel, so I am getting here u square minus v square which is equal to omega square of minus x1 square plus x2 square, and u square minus v square which is equal to minus taken common, so that x1 square minus x2 square I got. Rearranging the equation, u square minus v square which is equal to minus omega square, that is x1 minus x2 into x1 plus x2, a square minus b square is equal to a plus b into a minus b, so that I am writing this equation number 2. So equation 1 in equation 2, see there, equation 1 in equation number 2. So that u square minus v square, which is equal to minus omega square x1 minus x2 of x1 plus x2 value alpha plus beta divided by minus omega square. So minus omega square is get cancel. So u square minus v square, which is equal to x1 minus x2 into alpha plus beta. So value is replacing u square minus v square divided by alpha plus beta, which is moving from RHS side to LHS side, x1 minus x2.